Hey, physics. Okay, so let's talk about the relationship between mass and time when we're talking about stars. In the Star in a Box simulator, it had you put a star on a little scale, okay, and it told you over time what happened. It had, numbers here like 2.00, whatever. And over time, a star will expand, okay? So as it goes from its main sequence um, phase into the red giant or the blue giant, and then into a white dwarf, a neutron star. That all of that depends on the mass of the star. So you would have seen that in your Star in a Box lab. Okay, so when we're thinking about now, we've observed the relationship between mass and time. We know that over time, mass increases. Sorry, that's wrong. Let me try again. Over time, the star increases in size. Okay, increases in size. And it's a little counterintuitive because you think, okay, if the star is increasing in size, expanding, then the mass must also be increasing. But that's not true. The mass is decreasing. Mass decreases. Okay. So mathematically, when you're asked to represent this on a graph here with mass over time, I need to have something that has a negative slope. Okay. I need to show this indirect relationship between these two variables. Okay. So these are terms you're going to hear in math class that apply here in science. So over time, I can represent that as the mass starts off high, okay, starts off up here, and then over time, it decreases, okay? So if I collected data points over time, I could connect all of this with a smooth line to represent the trend of the data. So it's trending down because it has an indirect relationship. As time goes up, so time increases, then mass decreases. Okay, indirect relationship. So that is how you're going to mathematically represent what is happening to the mass of the star over time. Next, we need to talk about what's happening, like what is the reason behind this relationship. Okay, so why, if a star is increasing in size, right? Like what in the heck? Why is it not increasing in mass? Well, the reason for that is tied to what's happening at the center of a star. So when we're talking about the fuel of a star, we're talking about nuclear fusion. Okay, nuclear fusion. Okay, so inside of a star, I have a ton of hydrogen just bopping around, hanging out inside my star, okay? And a star is like a jawbreaker. It has different layers, okay? So there's a bunch of hydrogen in the middle, and if I take hydrogen and I stick it inside of a star, it's really, really hot, okay? And it's just like zooming around in there. And I have gravity pushing in, and the gravity is stronger than the fusion force pushing out, right? So it's just this big star oven that cooks the hydrogen, okay? So it makes it really, really high temperature. It's zooming around all over the place, and eventually one little hydrogen bumps into the other hydrogen. And because there's so much pressure and there's so much heat, then those two hydrogens, guess what? They become helium. Okay, so maybe if I do blue here, it becomes helium. He. See that? So now I have hydrogen and helium inside of the star, moving around at really high speeds, occasionally crashing into each other. Now, if we look at this collision close up, when I have hydrogen that fuses, combines, fusion is combine, fission is to split or to take apart. When I have hydrogen and hydrogen that combine to form my helium, okay, what happens every time I have that collision and that fusion is that I get a little bit of energy that comes off. So some heat energy is given off, and then I have my helium. Okay, so my 2 hydrogen are turned into helium. I've added more energy into the mix. Okay, and then over time, again, I've got hydrogen and helium, and they're just going around. And I might have more hydrogen combined into helium. But what happens if I have helium and hydrogen? Okay, so if I have helium and a hydrogen that bump into each other, helium plus hydrogen, what's the third element on the periodic table? So if hydrogen and helium combine, I want y'all to pull up a periodic table, okay, because this is going to be important to look at. On this side, far left side of the periodic table, right, I have my hydrogen. That's element number 1. It's the lightest element. 2, okay, I have helium. Helium's the second element, second lightest element. Next to that is lithium. Okay, so hydrogen and helium become lithium. So then I'm going to take out a hydrogen. Okay, and it's going to give off energy again. Energy is lost. Okay, and then I'm going to just add some hydrogen here. Okay, and add helium because I don't want to erase my helium. So what ends up happening is layer by layer. Okay, these elements actually separate. Okay, into layers. So when we look at the layers of the sun, a star holds all of these elements inside of it and is creating elements inside of that star all the way up to iron, the 26th element. Okay, so when it gets to iron, it's made a ton of elements. It gets to iron, and iron is the last. That's not an expo marker. Oops. Gets to the last step. Iron is like, we're done. We're not going to combine with anything anymore. And so it has to rely on the other elements and that hydrogen that it still has in order to sustain itself and to keep living. Okay. So when a star, after billions and billions of years, runs out of hydrogen, okay, it can no longer undergo this nuclear fusion process, so it's out of energy. It's like you drove your car and your car ran out of gas. If you don't go refill your car, it's not going to go anywhere, right? It's going to die. So stars, instead of just stranding you on the side of the road if you run out of gas in your car, stars are a little more dramatic, and if you have a high enough mass star, it explodes, okay? And then all of these elements from hydrogen up to iron spew out, okay? And so it just explodes, and it releases all of these trapped elements that were inside of the star, go out into the universe, okay? To then form a neutron star or a black hole, depending on the mass of the star we're talking about. So this week we're going to be talking about nuclear fusion, okay, and trying to understand more about what's happening inside of the star. You're going to play a game to simulate kind of the chances and the odds of these collisions happening. And you're going to work on an elaborate activity for that. So I hope you enjoyed the video. I hope it helped you out, and see you next time.